my team motion. Here's Ray Kamaforte, computer engineer, Q1, electrical, and Thomas Lee, electrical engineer. Riding a motorcycle can be dangerous, especially on normal highway activities. One moment of distraction could cause severe and often fatal consequences for the rider itself and those around them. And to combat this, we came up with the H.E.L.M.I.T, the HUD enhanced lightweight motorcycle interface technology. With this, we want to push the sensitive and often important data, such as speed, RPM, those sorts of things, onto the helmet, the motorcycle helmet itself. So there will be less distractions for the rider to experience, therefore adding additional safety. Now, granted, there are some competitors out there. For example, the P1 by Scully, which is due to be released in 2014. Also, the HUD, which is an independent project, is due to be written in August 2014 also. But these competitors suffer a few major drawbacks, actually. One is that the high cost of procurement. Their actual projects cost about $400 to $500 a helmet, and they're not very interchangeable. And also, they require additional tempering with the engine control unit that's available on motorcycles. Whereas our design, we promote the lower cost, the interchangeability, and the ease of use. With the ease of use, you would require simply plug in the OBD, onboard diagnostic tool, into the motorcycle, and you can immediately scan through the graph data. And second, once you have that installed and you see data coming in, you can simply plug, or rather clip, on the display unit onto your helmet, which can be anything that you buy from Walmart to professional biking shops, thereby adding its versatility. Over the semester, we have successfully acquired data that we can use from our motorcycle, or from a sample motorcycle. And we have successfully, as you can see here, made the hardware version of our display, of our display unit. All right, and moving forward, we would hope and we will accomplish the following: creating the data processing suite for our helmet itself, and the imaging suite for proper and easy displaying. The optics required to lessen the eye strain that the user might experience during normal travels and they're looking at our display. And finally, should time be allowed, we will go with cell phone integration for the whole plethora of functions and abilities that we can utilize on our helmet. Thank you for your undivided attention. Yes?
How does this attach to the helmet?
Simple clips and or Velcro.
Inside or the outside?
Currently, we're looking at outside because of the lack of space in the program, but it should be very easy to have.
And what's the processing platform?
Well, the processing platform will be using Raspberry Pi.
Why did you choose the Raspberry Pi?
It was the thing on hand, and we decided to build this because we have a software expert in the Pi.
How large, how physically large is this display?
The display itself, the actual LED display you mean, that should be, I would say, about 2 inches by 1 inch diagonal, 2 inches diagonal.
And so you're clipping this on and you will block some of the right.
This display is transparent.
Say again?
This display is transparent.
Okay, and if that's the case, how have you addressed the issue of being able to make sure that that's visible in a high brightness viewing situation, like riding into the sun?
Just like in movies. For that issue, we are currently looking at the optics to lessen the strain that the user might experience when they're looking at both the road and our HUD display. But as far as that's concerned, we might implement what do you call it? The auto damping mode? We will have some system worked out in case of that.
a volunteer who is generously supplied with a helmet and a motorcycle to test them on, as well as volunteer to actually test drive the unit.
Okay.
Yes.
Could you talk a little bit about how you're interfacing into the OBD port?
That will be software, and I will give it to you.
What we'll be using is a H.E.L.M.I.T Bluetooth adapter, which plugs directly into the onboard diagnostics port of the motorcycle, which is generally located under the seat. And our test vehicle, which is the 2006 Triumph Daytona 675, has that feature available. So we will plug that in to the OBD port, and we're able to successfully fit the system under the seat without any problems. So we'll be using that to acquire data, and we'll be sending that via Bluetooth to the Raspberry Pi unit. And from there, we will create a program in C to process the data to be able to send, for the Pi to be able to send it out to the spacer.
Okay. Have you verified on an actual motorcycle that you can read real time the information that you're looking for?
Yes, sir.